Hello, folks. We're going to go ahead and get started with our talk.
I'm Sean Jordan.
I'm Aiden Somerville. We're both digital forensics majors at Marshall University and fourth-year students.
So we created a Network Scout Twitter handle. If you have any questions, comments, concerns, you can actually tweet at us. We'll get an answer pretty quick. It's a good way to keep in touch, or if you have questions. My name's Sean Jordan. There's my Twitter handle. I graduate this May. Do home inspections as a side business. Didn't know anything about Python going into this. So.
And there's my Twitter handle. I'm pretty proud of it because it was there. I work as a server/busboy at Taste of Asia. So if you ever want to get your Chinese fix on, please come down and see us on 3rd Avenue.
Shameless plug.
Now. Alright, before we get started talking about Network Scout, we'd like to give a special shout out to people who funded us, including Marshall University and the College of Science, the Dow Chemical Corporation, and the Capitol Building, and we were actually able to present there about a month ago, and it was it was a big privilege to go.
Yeah, we actually got to meet one of the Dow guys and talk to him about Network Scout, and he was fascinated with it. So I think they're going to keep investing money into STEM grants, so fellow students keep applying.
Mm-hmm.
And then special thanks to Bill. He kind of issued the question that started all this and helped us get our grant, things like that. So now, Network Scout. So first thing we're going to talk about is why did we even do this? What is the need of Network Scout? And one of the reasons is there's been an emphasis on perimeter defenses. So we have our firewalls and our blinky boxes on the edge of the network, but nothing inside. So, or, if there is something inside, it costs a lot of money. So we wanted to take something that you could deploy across a network and report centrally. We talked about costs. This is open source, and we ended up keeping the costs fairly low. And then we wanted something that was easy to set up too. So, what it is, uses Dave Kennedy's artillery. It's an IDS and honeypot. It adds an additional defense layer, or additional layer of defense onto the network. We have that. And like I said, the subnets report centrally. So this is kind of like how we'd have it set up. You'd have a scout on all your subnets, and they would report back to a server. The server is written in Python, so it can really run on anything, but we've been using a Raspberry Pi. Through the course of this, we have like 20 Raspberry Pis. So it was just what we had. Then, Aiden, you want to do the hard side?
Alright, the hard side. Alright. Before I get started with this part, I'm going to give a special shout out to the Hackers for Charity and their rugged Pi design that we based. I think we have one going around now. We based our design off of it, and it's able to survive in multiple environments. And it's we made it to be waterproof, dustproof, and basically you can store it wherever you need to and forget about it. Alright, required tools. And here's a parts list that we have. You can find them all on Amazon. They're all very cheap, very easy to order and have shipped to your house. Yeah.
And then this is what...
Oh, yeah.
Hey, they only closed 1,000 stores. They're not... Well, I guess they did declare.
Yeah.
Yeah, Amazon.
Definitely Amazon. All right. Instead of Radio Shack, Amazon for everything. There's a picture of our design that we used. We have the LCD screen to display the IP address and whether the server or artillery is running on the device. The server will pick up all the communications from the nodes across the network. we added the button in order to turn the Pi on and off and run the script so that way it doesn't shut down like in the wrong way. In that picture is the Raspberry B Plus. Yeah, the B Plus. The only difference is it really uses the smaller SD card and a little bit more processing power. We haven't played around with the Raspberry
Pi 2 yet.
Yeah, but it's got a quantum processor.
Yeah,
Quad processor, yeah. And so that's pretty... I got quantum on the mind from the last talk. Yeah.
Yeah. $35.
Yeah, but it's all the same price, $35. The cool part is it's able to be built for under $150, and it actually saves a lot when you build the second machine because you have a lot of the parts left over from the first build.
So if you build two, which, I mean, it depends on your network configuration, you're looking at about $220. And what that would do is it give you a Raspberry Pi as a server and a Raspberry Pi as a honeypot IDS. So $200 compared to I looked online last night and they were hitting 5,000-10,000. And this is all open source, available on GitHub. So, and then here's the price breakdown. We also have a how-to guide. It's available on GitHub. I actually downloaded it for you guys, so I'm going to switch over. So this is available. It's already up on GitHub. It has the breakdowns, intro statements, how we built it, so you can see here where to drill the holes, how we cut the plexi. We learned early on you don't use a Dremel on plexiglass. You get a lot of odd fumes, fill the building, feel funny afterwards. It's just not good.
Yeah, we had to take a break after that. And the church we built them in wasn't really happy that the fumes were still there when we left.
But this will show you step by step, how we went about and build it. Also, will give you the commands, and like I said, this is already up, available on GitHub. So it's GitHub/Network Scout. So, yep. No problem.
No problem, man.
And there's also we didn't include the wiring diagram for the LCD, but it's available on Adafruit. You don't have to worry about the software side. It's just which plug goes where. And also, Bill will tell you he gave me one to build. And my dyslexia kicked in, and I plugged in the positive and neutral, did the opposite, and smoke was rolling out of his LCD. So luckily, it's $10. So
luckily, we were well funded, so we had multiple Raspberry Pis to mess around with.
And also, we're happy to announce we're actually going to be building these at DerbyCon this year. So you can come. We'll walk you through. We're going to solder. We're going to drill. We're going to cut plexiglass with the plexiglass cutter. So come join us. We're going to set them up and we're going to set them off. So
we'll do it the right way.
Yeah. And then we're going to go over the software side. So.
All right. Again, special thanks to Dave Kennedy, who was here before. He gave his talk about artillery and explained it way better than we could ever hope to achieve. But looking at his open source software taught us how to use Python in this way. And also to the Trusted Sec team and, I guess, Binary Defense. And there's our GitHub again. If you missed it the first time, it's right there. Gives you all the instructions on how to download the software and install it onto the Raspberry Pis or anything really that you want to use. All right.
And we're going to go through the program, kind of go through how it was set up, because the goal of this is to make it open source where anyone can take it and run. So we're going to go through kind of the code, how it's structured, and that way if you guys want to take it, deploy it, you can do things with it that maybe we didn't think of, or do custom things with it. I know I talked to Concealed at one point about getting it to talk to your firewall and maybe blocking things and doing things like that. So, we wanted to make it open so we could do this, but or have the community do stuff like that. But you'll notice in your network Scout setup, you'll have 4 folders. There's the stuff, the startup, the source and the website. All of this reports back to that server. That server generates a table with all the incidences. So I'll come back. Then we have your setup. We actually, after we built the scripts, we found out that it's really hard to get it all set up. So we built a simple setup script. So it installs everything for you. The only thing you have to do is tell your clients the IP address of the server, and you're done. So we wanted to make it super easy to set up. There's some controllers for like the shutdown button and the LCD controller, and we also have a configuration file inside, which is where you point to the server. And then Aiden's going to go over the server part.
All right. We also wanted to point out that one of our clients that called us in for help one time, they tried to set up artillery on the server, which made it not work. So if you ever want to download or use Network Scout, be sure that the server doesn't have artillery installed on it. It's just the reporting device. All right. Here's the Python script I used to build the server. I opened a TCP connection with all the nodes, able to communicate with up to 4 different ones at a time. It can be increased to up to about 10, I do believe. And I created the MySQL database, inhabited the logs as they came over the network, and then as soon as the table was inhabited correctly, I closed out the database and uploaded it to the website. All right.
And the client was kind of my kid, I guess. So what this does is it creates the Network Scout, make sure it's installed, and then in the loop it'll actually check the log file. I believe you can set any time you want. I think it's set for 10 or a minute. So every minute this thing checks the size of the log file. If you have something written to the log, it's going to send it out to the server, and we set that at 10 bits, and I mean, so that's anything that gets written to it. And then we had to then we have it connect to the server, send the log. So whatever's in there, it sends, and then it tries that first. So if it's not able to connect to the server, it won't erase the log. It'll keep it until it can actually connect. And then, you know, if there's any errors or anything, we print that out. And then I'm going to show you the send to server script we built. So it's just something really easy. Opens a socket, connects to the port, sends the file, the log path, and then closes it. So, and then some of the challenges we ran into when we started this project. Aiden had just did an independent study on Python. I didn't even know Python. Like, I was like, that's a language? What is that? Luckily, I took Dave Kennedy's code from Artillery and pretty much studied it until I understood the syntax and all that stuff, and then we ran with it. We also ran into the IP address and the shutdown, so if you tried to do a port scan running Artillery, it will catch you and it'll block you, and then you got the IP address, but you're blocked. You can't SSH or anything into it. So we built in the LCD screen, and what that'll do is it'll show you the status of the server or the client. It'll actually tell you if the process is running, and it'll also tell you the IP address. And then the shutdown button, if for some reason you have to do maintenance, instead of pulling the plug, we wanted to put a button in there so you can turn it down properly. You don't brick the SD card. Another fun thing we ran into is Artillery logging. So when we started the project, Artillery was supposed to log all the events that happen, and it was supposed to already have the server function ready to send. We couldn't get it to work. So what we ended up doing is I created a script that searches the Artillery file for the the create log, and it would inject a code underneath that would create another log in our directory, and that way we'd actually have all the events already recorded, ready to go. So it was pretty neat, and here's how we inserted it. So we'll walk over here. So it modifies the artillery file, it opens it up, and looks through the whole file, adds it underneath of the code, and then it's called Warn the Good Guys, is what our Dave Kennedy put in there. So it'll search, inject the code, and then save the file. So you, when you run artillery, it actually runs our code, a little bit of it, and but that was one way we fixed it. There you go.
Thank you. All right. On this next slide, we're going to go back to the server. We are trying to find out what server would work best for Raspberry Pis, and we found that the Linux, Apache, MySQL, and PHP, the open source software for the servers, work the best for us in this instance. There might be others out there that work better. Again, that's why we put our contact information, just in case like you guys knew anything else of it and wanted to get in contact with us. The setup it's not difficult per se, but we tried to make it as easy as possible, and we wanted to give a special thanks to JustBore. We found him on GitHub. There was a code that used to download or set up the script, or set up the LSAM script for you automatically. So without him, it would have been working on this for another couple weeks at least.
So like the first time we got this done, we gave it to Bill, and I was like, Bill, all you have to do these 10 steps. And Bill's like students, we're a little ADHD, we missed part of the steps, we didn't. So there was this problem getting it set up. So I was like, you know what, Bill inspired me to write an install script. I'm like, I'll make it real easy. Make it Bill proof. Yeah, that's the moral of this team's motto, is make it Bill proof. But so what we do is we set up artillery. It asks you what you want to do. So you can actually set up a server, you can set up a client, or you can exit or uninstall. You can uninstall Network Scout, and then you also just have the exit option in case you didn't want to run it. But so it runs through, does the options, and then here's what the install looks like. So if you pick option 2 here, you can see that we kill artillery, we move it into its own folder, and then we install the GPIO, which is what you use for the LCD screen, and the button. So downloads that for Python, and then we go through, we modify artillery, and then there was this part where I couldn't get, we ran init scripts, so you can do like service or network scout start, network scout stop, all that stuff. I couldn't get them to work. Spent like a day trying to figure it out, and I don't know if there's too many programmers, but then you realize it's permissions, and you just want to cry because you're like, I spent a day trying to get this thing to work. And yeah, so up here we ran into permission problems, and then the server, that's where the JustBore script came in from GitHub. It has an automated LAMP install, so we plug that in, and then it's pretty easy to create the server as well. And then to uninstall it, just goes through and deletes all the files. And there's the permissions. I just remember leaving that day, and I was like, man, I don't understand. I was like, I teach middle school kids Python, and I found a meme. It's like, I don't know why this code works. It's like the furious face or whatever. And it's like, I don't understand why it doesn't work. You have both sides. And then that's uninstall. And then
here's the Adafruit scripts running in the Python library. And this is all, we provided all this on our GitHub, so that way all you really have to do is type in a terminal command, and it'll give you all the scripts you need for either the client side or the server node. This one.
So something like else with the website is all the MySQL, all that stuff is set up on the server. You don't have to do anything. So when you're running the setup script, there's no need to worry about your server configuration, anything like that. We use Python, automated all of it. So when you take your little yellow box, plug it in, you just install what you want, put it out in the field. Like I said, the goal was simplicity. And this is kind of like the setup. So once you get it off GitHub, you run the setup. So Network Scout setup, there's your options. You just pick it and then you let it run. If you do the server, it does take like 30 minutes. I think I tell you to go get a cup of coffee, enjoy life. And then
you have to tell each individual client node the server address of the server the server pi, so that way they can report back centrally to it and update the website.
So that's just what the config file is for. As you can see here, you just can edit it with your favorite text editor, change the IP address, and then we're going to do a little slide of it in action here. So you can see here, this is just the website on the server, and then I did a port scan just using my Mac. Takes a couple of seconds to get the logs updated.
We're in the port scan right now, and after waiting about 10 seconds, it updates automatically. Another 5 seconds. As you can see, it tells you the attack number. There we go. The time of the attack and a message of the alert status of what happened and hopefully what you need to do to fix it. Like, generally, you don't want to see anything on that table. Like, it's all about, making sure that no one is doing anything on the inside of your network. So generally, if that table is empty, then that's a good thing.
Another thing is it'll tell you the IP address that it picked up, so that will tell you where your incident is. So find that computer, pull it from your network. And then finally, we're going to kind of go over the future of Network Scout. There's a lot of things that need to be done. There's some security on the server side. Moving some PHP around, some stuff like that. There's also some ideas of expanding it out. I know Bill kind of talked about maybe making it wouldn't just respond. It would also kind of like figure more out, I guess.
Yeah. Besides, hopefully being free still in the future, we came into contact with some people that wanted to use it and kind of privatize it, but that wasn't really our idea. Our idea was to keep it free to the public, just in case like any small businesses or local corporations wanted to like add an extra layer of defense for basically for free, because we wanted to keep it free since it was open source from GitHub. We just wanted to make sure it's still that way.
Another thing is this isn't like when we spoke at DerbyCon, we were kind of trolling a little bit, I guess, and said Target wished they would have had it and all this stuff. But honestly, the goal of this is to add a layer, just another, something that can identify an attack. If someone's in your network, you want to know. It goes back to like Dave Kennedy talking about the blue team. Like a lot of people are making red team tools. We really need more blue team tools too. Just ways to identify if someone has made it in your network. And when we were talking to the Dow guy, we compared this to, this is the buoy system on the Pacific coast. If you have a tsunami, you should get some reading back. Hey, something's happening. You need to look at this. And that's the goal of this, is we wanted something that was easy, cheap. You could put out, the Pi is $35, it's module, so if something goes bad in it, it's not, $1,000 to repair this. You can replace the SD card in 10 seconds with another $10 micro SD. You can buy a Pi for $35. So, we're not, it wasn't something, we want to make some expensive thing that we can make tons of money off. We wanted this to go out in the community and really be a benefit. And with that, we'll take questions. I know it's a short talk, and I apologize. Last time at DerbyCon, we had like 20 minutes worth of questions. So, yeah, Bill. Mm-hmm. I know it's the weekend of September 26th, because that's my birthday, so I'll be down there. And I don't know the cost of the training. I don't think they've announced it. But there's 15 slots for training, and they had 76 applicants. So, very fortunate to get selected. And we like to encourage people to go. It's a lot of fun. DerbyCon is an awesome conference. So,
DerbyCon is awesome. It's a very family-friendly environment.
Yes.
Yes.
So, you can at least come and get a free Raspberry Pi out of it.
Mm-hmm.
Well, yeah. In your goodie bag, I guess, your take home.
Yeah.
Anyone else have any questions? That's the idea. We really want to take it. There's some improvements that need to be made, like I said, in the security side. There's some ideas that the guys we talked to said LAMP wasn't necessarily the best option, so we may look at other server scripts, but it's coded in Python, so it should work essentially cross-platform, except for Windows, because I'd have to redo all the file. And that's another thing. I may look at it in a Windows sense and see if we can get it to run on Windows too. I know, but yeah. Some people asked about that at HackerCon. So. Mm-hmm. Yeah, when it sends the log, it'll say what actually happened from which IP. There's also an alert level system in the logs that hasn't been implemented yet. So we may modify Artillery a little bit more to get something out. There's also images available on GitHub of both the client and the server. If you want to, I know some people actually ask for direct, like I want to put the SD card in and just image it and then go. So that is available as well. So,
and any IP address acting suspiciously on the network was added to like the blacklist, and basically you couldn't access the server or the client node if it was on that list. And it was universal, so that way, like as soon as it was sent to the server, it was sent to the other client nodes as well. So that way, that one IP address would be isolated, and you can communicate with it on your network, which is good.
You could do stuff like that too.
Yeah.
Any other questions, comments, concerns?
Nope. All right. Thank you all so much.